Let's start from maybe the easiest thing to block or the easiest win to choose. So we are, if you think through Connect 4 strategy, you have to get how many 4 in a row. And the easiest position to look for is four vertical win, because that's just a single column, very few choices and complications. So if we look at this diagram here, we have kind of a description of what that would look like in the board. Ignore the letters for the time being. I'll get to what those mean and the colors, etc. So here we have 3 red pieces as represented by the 1s stacked up on top of each other. So the red player next turn will win unless yellow moves here. So in either case in this situation, you need to choose this column 3 here. So we can design a method that will look for 3 of a single color in a row and choose that column if this piece is empty and these 3 are filled with all the same color. But you might see here we have to design loops to look for this pattern here, 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 here. You get the idea, right? So these are all the originating squares in red. So you can look for this pattern from here down, from here down. But you can't start here and look for it down because you will go out of bounds. And so you have to design a method that will stay within the bounds that are required by the pattern. All right, so how do we go about doing that? Well, I'm actually going to build a new method. And the way I have this set up, in my head, this is the easiest. So we're going to have our method return an integer that will be the column choice. So let's say this method is called vertMove. And this method needs to know what the current layout of the board is. So we're going to ask for a copy of the board or access to the board in our parameters. And we're going to say, like, what color piece do you want me to look for? So we're going to say piece color. And then the way I have this set up is we're going to send back a -1 if we do not find the pattern we are looking for. So the -1 indicates indicates that we have not found a position here. So if we send back call choice as -1, we will know up here that we have not found any vertical moves, and so we should go on and look for other things. We're also going to take in a piece color, so we're going to be able to just use this method for both red and yellow rather than kind of programming it over and over multiple times to accommodate both pieces. So I'll show you how that looks in a minute. But now we need to construct these loops to look at every single row and column, and then we're going to limit them later. So let's just look at, these are the originating row and column locations for the pattern that we're going to check. So for int O row or something, if you want to remember, the originating row equals 0. We want to continue as long as, and we're just going to write these, well, let's do it correctly. So how long do we want it to continue? Well, we want it to continue as long as O row, and this board will never change in dimension, so you don't have to do like board.length minus whatever. We want it to continue as long as the originating row for the pattern we're going to check is within the bounds of the red square, so that we don't go out of bounds, because we're going to check this row, the one below it, the one below it, and the one below it. So we have to stop at 2. In other words, we want the loop to continue as long as the value of originating row is less than 3. All right, so as long as this is less than 3, each time through our loop we want to add 1 to the value of, I guess, O row, not row. O row. Okay, so that's the row loop. What about the column loop? Well, if we look here, are we limited at all with respect to the column values? No, because we want to check the final column too. So we want the column to go from 0 all the way up to 6 and stop before 8 goes out of bounds. All right, so let's just say like for int ocall equals 0, start at the first row, or start at the first column. We want it to continue as long as, on this, I wrote 0 row up here, O row. We want it to continue as long as the column is less than 7, so the 6 is the final index, and then just increment once every time through the loop. Okay, so now our strategy is going to be to look for that pattern. So how do we find that pattern? Well, there are a number of different ways to do this, but I'm going to try and do it in a way that's like very clear. So I'm going to set up an integer container for each of these areas, and that's why these letters are here, A, B, C, D. So I'm going to call this location, or the originating location, A, and then I'm going to call the one below it B, and the one below that C, and the one below that D. So no matter where it originates, this will always be A, B, C, D. This will be A, B, C, D. Okay, so we're going to check all of these locations for this pattern. So I'm going to say int A equals the board at O row, the originating row, and the originating column for our pattern check. For the sake of just ease of reading, I'm going to say +0 here. And then I'm going to copy this. And I'm going to make one for B, C, D. Rename these B, C, and D. And I'm going to take a look at, again, where I want those to be. So B is one row below A. No matter where that pattern, no matter where we're looking for that pattern, B will be one row below A. So B needs to be O row +1. C obviously needs to be O row +2, and this needs to be O row +3. And now we can do an if check to locate if we have found, or to demonstrate, to determine whether or not we have found the correct pattern. Remember, we will be sent a piece color, which will either be 1 or 2, red or yellow. And so this method will then say if A is empty, which is indicated by 0, right? So we want there to be, we want A to be empty, and then we want this to these three to either all be 1s or 2s, which will be indicated by piece color. So we want them all to be whatever piece color is. So if we say A is empty and B is the color we're looking for, and C is the color we're looking for, and D is the color we're looking for, we have found our pattern, and call choice then needs to be the originating column in which we have found this pattern. And that is actually the complete method, but now we still have to put it into use. So if we have found, to use this method, we want to say call choice, we want to say if vertMove with the current layout of the board and piece color red, let's see, oh no, not red, my color. We'll check for my colors first. We'll check for the opponent color first. So if vertMove, if there is an opponent's vertical move, and that's it, does not equal -1. So if we have found a vertical position for the opponent, indicated by this not being a -1, it will be some other column value here. If we have found what we're looking for, then we want to say call choice up here equals this, because this will now, since it's not sending back -1, it's sending back the column in which the pattern was found. Great. Well, but we also want to check for our wins, so that's how we check for blocking the opponent. But here, if we say my color and my color over here, we not only are checking to block the opponent, but we are going to be checking to affirmatively create a vertical win for our color. And that is how you check for vertical positions on in our Connect 4 program. In subsequent videos, we'll do horizontal position and then talk about vertical positions.